Welcome to the video presentation on Introduction to Power Generation, Transmission and Distribution. In this video, we will learn about the types of power generation, transmission and distribution. Let us start with the various activities performed by the power sector. The most important activities are power generation, power transmission and power distribution. Electricity is generated at different power stations. It is then transmitted through various channels like power transformers, transmission lines and transmission substations to the distribution substations. Finally, distribution substations distribute the electrical energy to residential and commercial consumers. The basic components of an electric power system are power generation plant, step-up distribution substation, step-down distribution substation, transmission lines and distribution system. Let us now look at the power generation plant. A power generation plant is a facility that produces electric power from various sources. They can be classified as conventional power and renewable power sources. The various types of conventional power sources are coal, gas, oil or diesel, nuclear energy and hydroelectric power, and the various types of renewable power sources are solar power, thermal energy and wind energy. Basically, all power stations adopt the same method to produce electricity. A turbine is made to rotate and a generator is attached to the shaft of the turbine. As the turbine rotates, the generator produces electricity. This electricity is sent out through transmission lines to a distribution station of the various electricity boards. Let us look at the process of producing electricity of a few power plants. Let us start with coal-based power plant that generates power by using coal, gas, oil or diesel. These power plants use a four-step process to generate electricity from heat energy. Let us know these steps. Fossil fuel like coal, gas, oil or diesel, when burnt, produces heat. This heat is used to boil water to produce steam. This steam turns a turbine. The turbine drives a generator which produces electricity. This electricity is passed through transformers to produce electric power of the desired voltage. To run a hydroelectric power plant, a dam is built on a large river. This is to create a substantial drop in the elevation. The force of the flowing water turns the turbine propeller. The shaft of the turbine is linked to a generator, which produces electricity. Solar photovoltaic generation produces energy by using either parabolic troughs or heliostats. These are sun tracking mirrors. The central tower type of solar thermal power plant uses hundreds or thousands of mirrors depending on the plant size. These mirrors direct sunlight onto a receiver on top of a tower. The heat generated is used to produce steam. The steam turns the turbines that drive the electrical generators. Let us next look at a nuclear power plant. In a nuclear reactor, fuel rods are placed in water. These rods release energy. This energy heats the water, creating steam. The steam moves through a turbine and turns a generator to produce electricity. Later, the steam condenses into water, which is used again. Let us next look at a wind power plant. As the wind blows over the blades of a wind turbine, it causes the blades to lift and rotate. The rotating blades turn the shaft that is connected to a generator. The generator produces electricity as it turns. The electric current generated in the power plant has to reach consumers. For this purpose, several substations are arranged between the generating station and the consumers. A substation is a high-voltage electric system facility. It is used to convert generated voltage to EHV for transmission of power to long distances to the load centers through transmission and distribution system. The generated electric power flows through several substations at different voltage levels before it reaches the consumer. The various types of substations used to transmit electric power are step-up transmission substation, step-down transmission substation, distribution substation, and underground distribution substation. Let us now look at next component of electric power system, transmission lines. Transmission lines carry electric energy from one point to another point through an electric power system. The transmission lines are operated at relatively high voltage. This is to transmit large quantities of power over long distances. Overhead transmission lines carry large quantities of power at EHV to long distances. The voltage varies based on the grid to which they belong between 66 kV to 765 kV. Sub-transmission lines carry voltage reduced at lower voltage from major transmission line systems. The voltage is between 33 kV to 66 kV. Voltage is stepped down to 11 kV at the substation and then to 400 volts through distribution substation for use of industrial, commercial, agriculture and domestic consumers. Electric current is distributed to the consumers through a distribution system. The distribution system originates at 33 by 11 kV grid substation and consists of many facilities and equipment. They are lines, poles, transformers and other equipment needed to transmit electric power to the consumer's place at the required voltage. Let us look at the components of distribution system. A substation is a high-voltage electric system facility. It is used to step up the voltage for transmission at long distances and then step down the voltage for distribution of power. Distribution feeder circuits are the connections between the output terminals of a distribution substation and the input terminals of primary circuits. Sectionalizing switches or GO switches are installed at strategic locations to redirect or cut off power flows for load balancing. Protective equipment consists of protective relays, cutout switches, disconnect switches, lightning arresters and fuses. Primary circuits are the distribution circuits that carry power from grid substations that carry 33 by 11 kV and 66 by 11 kV to substations with 11 kV lines to local load areas. Distribution transformers reduce the voltage of the primary circuit to the voltage required by consumers. Secondary distribution system includes the LT feeders originating at the low voltage secondary winding of a distribution transformer. Service wire is the wire extending from the secondaries or distribution transformer to a consumer's location. Through greater operational efficiencies and better load management, we need to deliver quality services to our customers.